Volume. Today we're going to move our geometry study into 3 dimensions to calculate some volumes. Volume is how much stuff can you fill into some 3-dimensional object. And a lot of people, when they study volume, memorize lots and lots of different formulas, and I think that's way too much work. We can simplify it down to 3 types of volume formulas. We're going to often see this capital letter B. This capital letter B is always going to represent the area of the base. The base can be lots of different shapes, and we already know how to find the area of various shapes. B is the area of the base. So the first type of volume formula is for some type of prism. We have the special type of prism called the cylinder. The cylinders where you've got a circle for the top and bottom. But the idea of a prism is the same shape on the top. A circle in this first example is the same shape all the way through on the bottom. Whether it's a triangle in this second example, going all the way through to the bottom is a triangle. The square in this next example goes all the way through as a square. It's 2 bases. The top and bottom are the same. That's a prism. And the formula for the area of a prism, and this is a good one to memorize, is simply the area of the base times the height. Base times height. Now a slight variation on these shapes is what is called the prism or a cone. The prism is going to have some shape on the bottom. Maybe it's I think this one's a hexagon. Next one's a square. Or if it's a cone, it would be a circle. But the idea is the same. Same shape on the bottom, and it comes to a point at the top. So all the sides are either triangles or they're round in the case of the cone. And it doesn't matter which one it is, as long as it's got that general shape of a base on the bottom coming to a point at the top, the volume is 1/3 of the prism volume. 1/3 of the base times the height. The only other formula is the sphere. That's something that's round on all sides, so it doesn't really have a base. The common definition is it's a ball. And the formula for the volume of a sphere is 4/3 pi r cubed. So there's really only 3 formulas you need to know to calculate the volume of all sorts of shapes. So here's 3 examples. We're going to try and find the volume. How much stuff is in all of these? So we're going to start with this first shape. You'll notice this first shape has a circle for the base, and it comes to a point at the top. That means we are dealing with a cone. Same formula, though, as a pyramid. It is 1/3 times the area of the base times the height of the shape. So we need to find the area of the base, and in this case, the base is a circle. The formula for the area of a circle is pi r squared. And we know pi is 3.14. And r, the radius, if the entire distance across is 12, half the way across must be 6 centimeters. So 3.14 times 6 squared, or 3.14 times 36, which we'll do on our calculator really quick. 3.14 times 36. Is 113.04. So now that we've got the area of the base, the volume is 1/3 times the base, which is 113.04, times the height, which is straight down the middle. It's really important if they give us the slant height, the diagonal part, we have to find some way to calculate the actual height. We want the actual height of the cone, not the slant height. The actual height here is 7 centimeters. That 1/3 is the same as dividing by 3, so I'm just going to do on my calculator 113.04 times 7, and then divide that answer by 3. To get my final volume of 263.76 cubic centimeters. For my second shape, we're dealing with a triangle base. And you'll notice that triangle base goes all the way through the shape. It's the same shape all the way through. So we are actually dealing with a prism, and the volume for a prism is equal to the area of the base times its height. And in this case, the base, as we said, is that triangle. And so the volume, the area of the base, the area of a triangle is 1/2 times the base times the height of the triangle. And remember, the base and the height meet at a right angle. So we've got our right angle here, so our base and height are the 7 and the 6. Remember, base and heights do not mean bottom and up. Base and height have to be perpendicular. So the 7 and the 6 are what are perpendicular. So 1/2 times 7 times 6. And 7 times 6 is 42, and so we end up with 21 is the volume, or the area, of the base. So now we go to base times height. The area of the base was 21. The height is what connects the two bases together. That's the 18 centimeters. And so my volume on the calculator is simply going to be 21 times 18, or 378 cubic centimeters. This last example is a ball or a sphere, and we know the volume for a sphere is 4/3 pi r cubed. And so we're just going to go straight to plugging stuff into that formula. Volume equals 4/3 times pi, which is 3.14, times r, the radius, which it gave us. The center to the edge is 10 cubed. And I'll go ahead and do that 10 cubed on my calculator. So the volume is equal to 4/3 times 3.14, and 10 cubed is 1,000. And remember, that fraction of over 3 means we divide by 3. So 4 divided by 3 times 3.14 times the 1,000 gives us a volume of 4,186.67 meters cubed. And now we've got the volume of our sphere. To wrap up this volume discussion, I've got one more interesting volume problem. Is if you look at a pizza, and if your pizza has a depth of A, which we also know is the height, and a radius of Z, a pizza is really just a really thin cylinder. So the volume is equal to the base area times the height. Well, the base is a circle, and so a circle is going to be pi times the radius squared times the height. So as you can see, the volume of this pizza is pi times the radius, which is z squared, times the height, which is the depth of A, which means the volume of the pizza is pizza. Whoa. Take a look at the homework assignment tonight, and let your instructor know if you have any questions on calculating these volume formulas.